diabetes. So in medical science, when scientists study diseases, they need to trigger that disease in animals. Because if you try to find a mouse that has Alzheimer's, a mouse that forgot what a cat is, you won't find one. If you try to find a mouse that has Parkinson or multiple sclerosis, you won't find them. You need to find a way to trigger a disease that resembles it or it's identical to what we have in human, and then we try to find a way to cure it. For diabetes, this is a nitrate of Langerhans. This is the unit in the pancreas that makes insulin, and scientists have discovered a bacterial toxin. When you inject it in a mouse, this within 2 days will become this. So these animals no longer make insulin. They are insulin-dependent diabetic mice. So in order to survive or not develop problems linked to diabetes, we need to inject insulin. So the third group of mice did the same thing, injection of streptozotocin plus endogenous stem cell mobilization. And you can see partial recovery of the islet of Langerhans. But that's enough to rescue these animals. You only need 40% of your pancreatic function to not be symptomatically diabetic. So this was enough to rescue the animals. A very similar study was done in 14 humans recently diagnosed for insulin-dependent diabetes, and they got 2 rounds like this of stem cell release, and of these 14, 13 had been insulin independent for anywhere between 3 to 36 months. When the study was over 3 years later, some of them were still insulin independent. I'm not telling you we found the treatment for diabetes. I just want to show you that stem cells have the potential of becoming cells of the pancreas making insulin. They can have an effect on the ability of the body to repair itself with regard to pancreas.